Hello everybody and welcome to Infinity the Math Institute. I'm Mr. Bru and I'm here to give you some solutions, not more problems. Today we're going to be talking about the rules of exponents. This is something that's going to come up consistently, learning in middle school and using in high school and college. And you just understood that you understand it. So let's get through the 9 rules, and I'm not going to tell you to memorize them per se. I'm going to show you the concepts which will lead you to understanding it, which will make you not necessarily memorize the formula, but be able to utilize the formula anytime you want. Rule number 1, x to the a times x to the b is x to the a plus b. Meaning, when multiplying like bases, you can simply add the exponents. A real life understanding would be if you have x squared times x cubed, x squared is x times x cubed is x times x times x. When you multiply all of these, obviously you get x to the 5th, which proves that you simply add those two exponents. Rule number 2 is kind of the same as rule number 1. X to the a divided by x to the b is x to the a minus b. So when you're dividing like bases, you can simply subtract the exponents. For example, if you have x to the 5th over x to the 3rd, you end up getting 5 x's on the top and 3 on the bottom. We all know x over x is 1, x over x is 1, x over x is 1, so we're left with 2 of them, which would give you x squared. You simply subtract the exponents. Rule number 3, power to a power. X to the a to the b is simply x to the a times b, and let me show you why. If we have x squared cubed, that means we take x squared 3 times. X squared cubed is x squared times x squared times x squared. We all understand that x squared is x times x, x times x, x times x, which gives us a total of 6 x's, which will help you remember that we multiply these two exponents. Guys, I was always good at math, but even when I was in middle school and high school, I didn't remember these rules. I always had to go back and do this in my head to remember which rule went to which, and that's why I'm telling you, don't memorize the rules, memorize the concepts. Some other things that you absolutely need to know. Anything to the 0 power is equal to 1. It doesn't matter what it is. Anything to the negative first power is simply the reciprocal. We're simply going to put whatever is to the negative exponent. To get rid of the negative, we simply put it in the denominator. So x to the negative 1 is actually 1 over x to the first. If this was x to the negative 2, it would be 1 over x squared. Get rid of the negative by putting the base on the other side of the fraction. If it's on the denominator with the negative exponent, we're going to move it up. If it's a negative exponent in the numerator or not in a fraction, we're going to put it down to the bottom. Over here, this just explains this a little bit more in detail. A over b quantity to the negative n, you take the reciprocal to get rid of the negative, and then you distribute the power to both terms. So the b goes to the top, and it's to the nth power. The a goes to the bottom, and it's to the nth power. So anytime you have negative reciprocals, negative exponents, you must think reciprocal. X to the 1/2 is something you see quite often, and when you see rational or fraction exponents, we're going to take it to the root of the denominator. So you guys understand, when you got the square root of x, there is an imaginary 2. And this is always to the first power, which brings us to the next rule. Anytime you have a rational or a fraction in your exponent, you're going to take the b root to the a power. The b root of x to the a power. And we're going to be working on an example in just 1 second. Finally, this is just something to make sure you guys are clear with the distribution rule. If you have a quantity to a power, that power will be applied to each quantity, especially if this first quantity, this a, is a constant. I see kids messing that up all the time. They'll leave the constant alone and distribute the exponent to b and c. Don't be that person. always distribute the n power to all the terms. So let's take a quick look at a couple of examples. First of all, we have x squared y to the third times x times y squared. All right, kids, remember, when you see this multiplication dot right here, that don't mean nothing, right? This means x squared times y to the third times x times y squared. So sometimes your worksheets and stuff will have this multiplication sign. It doesn't matter. It doesn't. Sometimes you'll see parentheses. It doesn't matter. When we're multiplying, we have the commutative and associative properties of multiplication. So all of that is just extra fanfare. So we simply take the like terms and add the exponents. There's an imaginary 1 here. So x to the 2 plus 1 is x cubed. Y to the 3 plus 2 is y to the 5th. It's really that simple. I could have drawn it out, x times x times x times y times y times y times y times y, but we understand we have our shortcuts. All right, power to a power, and we're going to distribute it. So this means 2 to the 5th, x to the 5th, and y squared to the 5th. Now you might be able to skip this step, but I just wanted to illustrate it so you're totally clear on it. So 2 to the 5th power is 2, 4, 8, 16, 32. X to the 5th power is x to the 5th power. And y squared to the 5th power to a power is simply y to the 10th. All right, don't make these out to more than they have to be. These are really easy problems. Just make sure you understand these concepts. 27 to the 2/3. Again, a over b means the b root to the a power. So we're going to take the cube root of 27 and put this all to the second power. All right, the cube root of 27 is 3, because 3 times 3 times 3 is 27. So it's 3 squared, and we all know 3 squared is 9. So 27 to the 2/3 is simply 9. And then finally, these are the most difficult problems you're going to get. Right here, I got x squared y to the 3rd, quantity to the 4th power, all over x to the -1, y to the 3rd. All right, there's a bunch of different ways I can approach it. If I follow my properties and my instructions, it doesn't matter which order you go in. Just follow the properties. Me personally, I'm going to distribute the top first. So I'm going to end up with x to the 8th over y to the 12th over x to the -1, y to the 3rd. All right? And then I'm going to bring this x to the top to get rid of that negative. So I'm going to have x to the 1st times x to the 8th, which is x to the 1 plus 8, which is x to the 9th. And here I have y to the 12th over y to the 3rd. Y to the 12th over y to the 3rd is y to the 12 minus 3, which is y to the 9th. And this is over 1. There's nothing left in the denominator. You don't have to draw the 1. It's just understood to be there. I would simply write x to the 9th, y to the 9th. That's everything, exponents. Please look up some extra practice, and if you need any more help, you know where to go, themathinstitute.com.